All right, hi everyone. We're going to briefly touch on Lesson 12. I won't test you on this, but these ideas in Lesson 12 we do take through the year. So I want to start with briefly this first warm-up question. It says there are 2.45 centimeters in an inch, 12 inches in a foot, and 5,280 feet in a mile. Those are good numbers for you to remember as you go through your life. The question says, which expression gives the number of centimeters in a mile? So let me think this through. How would I find centimeters in a mile? Well, here's a great big mile, right? Miles are long. If I want to go from 1 mile down to centimeters, I need to cut that. There should be a whole lot of centimeters in a mile, right? So 5,280 feet. And then there's 12 inches in a foot. So there's 5,280 of these increments of these little feet in 1 mile. And in each of those feet, there's 12 inches. And so if this was a foot, there's 12 inches in there. And in each one of those inches, there's 2.54 centimeters. That 2.54 centimeters is an exact value, not a rounded value. Not many things in this world are exact, but 2.54 centimeters exactly in an inch. So how do I figure out how many centimeters there are? Well, there should be a lot of them, right? 2.54 centimeters in every one of these inches, 12 inches in every one of these feet, and 5,280 feet in that mile. To get that big number, I'm going to multiply. I wouldn't divide, I wouldn't add, I wouldn't divide, I would multiply. Okay, so this unit talks a lot about metric conversions and conversions. Again, we'll work on this through the year. It's not a huge idea for us today, but I do want to run through it because it's going to come up later. This next question talks about the world's largest flag. So this is a flag of the country of Tunisia. And it says, as of 2016, Tunisia holds the world record for the largest version of the national flag. It was almost as long as 4 soccer fields. It has a circle in the center, a crescent moon in the inside circle, and the star inside the crescent moon. Complete the table. Explain or show your reasoning. So it's telling us we're using a 1 to 2,000 scale. So the 2,000, that would be the actual size, right? The real size of this world record-setting flag. So our scale is going from here to here, multiplying by 2,000, or from here to here, dividing by 2,000. What we have to be aware of here is the units that we're working on. So let's see, if I'm going from 396 meters and I want to figure out how many centimeters that is, I will divide by 2,000. So I have this one, I need to go down here, I'm going to divide. And if I divide that 396 by 2,000, I get 0.198. But that 0.198 would be our measurement in meters. Because again, we have that scale, right, with no units. That means we use the same unit twice. So if I divide meters by 2,000, I'm going to get meters. But that's not what we're looking for. We want that unit in centimeters. So how do I go from meters to centimeters? Let's see, every one of my meters has 100 centimeters in it. So I'm going to take my answer, that 0.198, and I'm going to multiply it by 100 to get my number of centimeters. And if I multiply 0.198 times 100, I get 19.8 centimeters. Okay, so there's 2 conversions happening here at the same time. We're going meters to centimeters or centimeters to meters. Let me do, while I'm up here, I'll do this 99 meters. 99 divided by 2,000 would give me 0.0495. And then multiplying that by 100 would give me 4.95 centimeters. If I'm going the other direction, I want to take that 13.2 and multiply by 2,000. So to go from here, multiplying by 2,000 gives me 26,400 centimeters, but then to get that down to meters, I'm going to divide by 100, which would give me 264. Okay, so make sure we have the right units is the idea here, okay? I'm going to skip this question. Question number 3 says, what is the area of the large flag? Well, let's see. Our large flag was in meters. Its length was 396. and its height was 264. And we remember how we get area, we multiply length times width. So 396 times 264 is 104,544. And when we talk about area, we talk about meters squared or centimeter square or square feet. We use that idea of squaring. So we say either meters with a little 2, or we could say square meters, something like that. Okay, so our unit is important there. What is the area of the smaller flag? Well, I could multiply that 19.8. That came from my chart. 19.8 came from here, times 13.2, and I would get 261.36 centimeters squared, or square centimeters. The area of the large flag is how many times the area of the smaller flag? Well, I'm going to take those two numbers and I'm going to divide them out to figure out how many times larger I would divide. So I'm going to take the numbers 104,544 and I'm going to divide by that 261.36. 104,544 divided by 261.36 gives me 400. And why is it 400? Well, we scaled up by 2,000. So 2,000 in this direction and 2,000 in this direction. So both directions multiplied by 2,000. But then we divided by 100 in this way and 100 in this way, which knocked off some zeros. So 20 times 20 gave us 400. Again, that's kind of a long, complicated problem. Don't worry about it too much now. I just wanted you to see that before we move on this year. So this question says, Lynn and her brother each created a scale drawing of their backyard, but at different scales. Lynn used a scale of 1 inch to 1 foot. Her brother used a scale of 1 inch to 1 yard. So because these two scales are different, we should put them into the same unit before we move on. So Lynn uses 1 inch to 1 foot. Her brother uses 1 inch to 1 yard. That's 1 inch to 3 feet. 1 yard, or 1 yard is 3 feet. And then it says, express the scales in drawings without units. So we could do 1 to 1 to 1. We could do 1 to 12. We could do 1 to 36, because there's 36 inches in a yard. Question says, whose drawing is larger? So let's think about this. If we imagined their backyard being, let's say, 60 feet by 90 feet, okay? 60 feet by 90 feet. For Lynn's drawing, the size would be, if she's using 1 inch to 1 foot, her drawing would be 60 inches by 90 inches. But her brother is using 1 inch to 3 feet. His drawing would be 1 inch to 3 feet would be 20 inches. Sorry, put that in the wrong place. 20 inches by 30 inches. So which one's bigger? Well, hers is bigger, and we remember that because the smaller the scale, the larger the drawing. The bigger the scale, the smaller the drawing. Now, I know we asked you to try question 3 in the practice problems. I'm going to skip it for now, though. And now that I'm looking at it, it's more confusion than it's worth. And we'll go over questions like these again as the year goes on. And we'll skip ahead to number 5 and number 6. Number 5 says water comes in, costs $1.25 per bottle. At this rate, what is the cost of? And it gives you different numbers. So we could think of this as a T-chart. The number of bottles and the cost. What's going to go over here for our unit rate? Well, it's 1 bottle cost $1.25. And now we could figure out how much 10 bottles cost, 20 bottles cost, 50 bottles cost. And again, going from here to here, I'm multiplying by $1.25. That would give me $12.50 for 10 bottles, or $25 for 20 bottles. Or if I do 50 times $1.25, I should get, I believe that's $62.50. And you can check my math on that one, okay? Again, it's just finding that scale factor, right? And we're going to multiply by 125. We have a similar question down here asking us about the amount of dish detergent needed to make a soap solution. And it says complete the table for 2, 3, and 4 batches. So our scale factor going from the number of batches to the number of cups of water is times 6. And going from the number of batches to the cups of detergent is times 1. So this should be easy enough. 2 times 6 would give me 12. 3 times 6 would give me 18. 4 times 6 would give me 24. And then 2 times 1 would be 2. 3 times 1 would be 3. And 4 times 1 would be 4. And then we're about done. Okay, so make sure you have your work checked and then get started on the review sheet. I will post the answers to the review sheet sometime on Wednesday. Okay, and we'll have test Friday. Thanks, guys. Have a good day.